Today I am going to solve one thermodynamics as well as numerical method in chemical engineering problem. So problem is here, methanol is formed by reacting carbon monoxide with hydrogen. This might be an onboard generation of hydrogen for the hydrogen economy. With the reaction carbon monoxide plus 2 hydrogen that will produce methanol. So here carbon monoxide and hydrogen produce methanol, that is reversible reaction, means forward as well as backward reaction is happening here. The condition at equilibrium means when forward reaction and backward reaction will be equal, so that time we call it reaches an equilibrium. Now here the condition at equilibrium is Kp is equal to partial pressure of methanol divided by partial pressure of carbon monoxide into partial pressure of hydrogen square. And if we convert that partial pressure of methanol, carbon monoxide and hydrogen, so we'll get mole fraction of methanol by mole fraction of carbon monoxide into mole fraction of hydrogen square into 1 by P square. Now when the carbon monoxide and hydrogen enter the reactor in a 1:2 ratio, find out the equilibrium conversion when the pressure is 50 atm and Kp is given, Kp is 0.0016, and use Excel we have to find out the equilibrium conversion. Means in the reactor carbon monoxide and hydrogen ratio is 1:3 and everything is given. Now we have to find out the equilibrium conversion. So you have to solve this problem. First, here to solve this problem, so I am taking the basis. Basis is 1 mole of gas mixture enters the reactor. Now 1 mole gas mixture entered the reactor and the ratio of carbon dioxide and hydrogen is 1:2 in the gas mixture. Now we can easily calculate what will be the carbon monoxide entered the reactor. So that will be 1/3. And hydrogen in the gas mixture means hydrogen entered in that reactor, so that will be 2/3 moles, 1/3 mole, 2/3 mole. Assume X mole of carbon monoxide is converted. And initially that carbon monoxide is 1/3 mole, hydrogen in the gas mixture is 2/3 mole. Assume X mole of carbon monoxide is converted and reaches an equilibrium. Now we know that equation, carbon monoxide plus hydrogen, that will produce methanol, and we know from that stoichiometry 1 mole of carbon monoxide reacts with 2 mole of hydrogen and produces 1 mole of methanol. Now we can calculate component in a tabular form. So here, so now in that side I have written that components, carbon monoxide, hydrogen and methanol, and total initial time at t is equal to 0. So how much amount carbon monoxide is there? So that is 1/3 mole. How much hydrogen is there? 2/3 mole. So no methanol actually producing at that t is equal to 0. So what will be the total mole of the gas mixture? So that is 1 mole. So that is that basis we took. Now at equilibrium we assume that X mole of carbon monoxide is converted. So how much? So X mole carbon monoxide is converted. Then how much mole still remaining? So that is 1/3. Originally 1/3 minus X. How about hydrogen? So you know 1 mole of carbon monoxide reacts with 2 mole of hydrogen. So X mole is actually carbon monoxide converted. So how much hydrogen is needed for that conversion? 2x mole. Now how much remaining? 2/3 minus 2x. And how much methanol is produced? So that x mole. So at equilibrium in that gas mixture, how much mole is present? So if you add that 1/3 minus x, 2/3 minus 2x plus x, so that will give the 1 minus 2x. Now if we calculate the mole fraction at the equilibrium, so this is mole fraction means what? Individual mole by total mole. So total mole is here 1 minus 2x, and individual mole present at equilibrium, so that is 1/3 minus x. So mole fraction will be 1/3 minus x by 1 minus 2x, means 1/3 minus x is the individual mole, by total mole is 1 minus 2x. Similarly mole fraction of hydrogen at equilibrium, so 2/3 minus 2x by 1 minus 2x. And methanol mole fraction at equilibrium, so that will be x by 1 minus 2x. Now we know if we add all these mole fractions, so that will be equal to 1. Now we already have this table. Now the condition at equilibrium is we know Kp is equal to mole fraction of methanol by mole fraction of carbon dioxide into mole fraction of hydrogen square by 1 by p square. So now we can put already we have the mole fraction. So Kp will be x by, that is the methanol mole fraction, x into 1 minus 2x, and then carbon dioxide mole fraction 1 by 3 minus x by 1 minus 2x, and hydrogen mole fraction will be 2 by 3 minus x and 1 minus 2x whole square, and into 1 by p square. Now so we got this equation. Now if you put the Kp, and now here in that next slide, this is the equation. Now if we solve, simplify this equation, to 2x and 2x will be cancel out, so we'll get Kp is equal to x into 1 minus 2x square, then 1 by 3 minus x and 2 by 3 minus x whole square, and y by p square. Now if we put the Kp value is 0.0016 and p value atm is 50 atm. So if we put all this and simplify, then we will get 0.0016 into 50 square is equal to x 1 minus 2x square, and divided by 1 by 3 minus x, 2 by 3 minus x whole square. Now if we take everything in that left hand side, so 0.0016 into 50 square minus whole equation, that will be equal to 0, and that is nothing but function of x. Now here we have to calculate x and solve this equation, and that x will be the conversion, means how much converted, so that we will get. And after getting x, now what will be the mole fraction of carbon monoxide, hydrogen as well as methanol, that we will get. Okay, and we can solve this equation by using Excel, MATLAB, bisection method, neutron adaptation method, that numerical technique where we can find the root of the equation. So here by using, this is the nonlinear equation, so we can solve this nonlinear equation and we can get the x. So this can be solved by Excel goal seek, Excel solver, neutron adaptation method, bisection method, we can secant method, we can do that. So Excel, how to solve this problem, I will show you in the next. Now we already got the nonlinear equation, that is fx is equal to 0.0016 into 50 square minus this equation, and we are solving this problem by using Excel. Now here we took the basis 1 mole, and ratio of carbon monoxide and hydrogen is 1:2. Now that carbon monoxide here how much, so that will be 1 into 1 divided by 3, so that is that carbon monoxide, and hydrogen is, that is 1 into 2 divided by 3, so that is and methanol, initially we don't have methanol, so at initial time that is carbon monoxide is this amount, hydrogen is this amount, and methanol is this amount, and total will be, that will sum of all these 3, so that will be obviously 1. Okay, now we consider conversion of x. Conversion means, suppose we have here we am taking that some gas value, suppose 0.1 mole carbon monoxide is converted, this is the gas value. Okay, so this is the gas value, currently I am taking that gas value. Okay, the gas 0.1, so at equilibrium how much carbon monoxide is there, so that will be, that is equal to this minus that x amount, so I am taking x is gas value, so that amount. How much hydrogen is there, hydrogen will be that this amount minus 2 into x that we got from this table, that is 2 into that x, and then how much methanol will produce, so that is x amount, so here x I am taking that gas value, this amount. Now what will be the total amount? Total amount will be right now this, and then so what will be the mole fraction? Mole fraction means individual mole divided by total mole, so that will be the mole fraction. And again, so similar way, so individual mole divided by total mole, so that is mole fraction of hydrogen. again for that mole fraction of methanol divided by that mole fraction, total mole fraction, so that is this, and if we add that, so that will be 1, right? Now our equation is this, so we have to write that equation. So here Kp value is given already 0.0016 and P is this. Now here I am taking that, I am writing that equation. So equation is this Kp into that P, that's whole square, and then minus we know this is the mole fraction of methanol. Mole fraction of methanol is this one, okay, divided by that carbon dioxide mole fraction. Carbon dioxide mole fraction is here, this is carbon dioxide mole fraction into mole fraction of hydrogen square. Mole fraction is here hydrogen, this square, okay. Now so we will get that equation. So this is the this value. Now from here we have to use goal 6 and find out the solution of this equation. Now for that we have to go to the data, okay, and then what if analysis, goal 6. So that is that F11 we have to do as a 0 by changing this value. If you press OK, so it will give the result, okay. So now this is not a guess value, so that x is this, means 0.1668015 that mole of carbon monoxide is converted. So now remaining that mole fraction of carbon monoxide is this, hydrogen mole fraction at equilibrium, and that at equilibrium that mole fraction of carbon monoxide is this, mole fraction of hydrogen is this, and mole fraction of methanol is this, and mole of carbon dioxide is this, mole of hydrogen is 0.33, and methanol mole is this amount, okay. So now we can solve that equilibrium conversion. It is 0.116, that is that much amount of carbon monoxide is converted, and that we got the mole fraction of all this component. So that's it. So we solve, this is the answer we can say, okay, and this is the mole fraction of all this component. That's it. Thank you. I hope you understood how to solve by using Excel. First we have to formulate that equation, and then we'll do the goal 6 and we'll get the conversion.